Okay. So I'm on page 169. Remember, you get a full sheet of paper for tomorrow, which always cracks me up when it's like, oh, I didn't know I could do that. Kid you not, it happens all the time. So, all right, page 169. It says the length of a jury trial related to the amount of time it takes a jury to deliberate. The verdict statistics from a small subset of the trial are provided below. All right. So let's make sure we feel good about plugging this into Desmos. What'd I do? I probably did something bad. Five, 12, 18, 5, 10.5. 5, 2, 1.5, 3.5, 5.5, 2, 3, 4.5, 3.5, 8, 2.5, and 3.5. Okay, here we go. So they want us to create a linear regression based on this model, which it doesn't look incredible. Kind of look like a blob. So linear regression, we're just going to go y sub 1 tilde mx sub 1 plus b. So it says find the correlation, explain what the meaning is in the context. So our correlation is negative 0.75. It's relatively, well, it's kind of strong, not really. I mean, 0.75 is like pretty bad. It appears that that the longer the jury deliberations, the longer the trial, something like that. And then explain the meaning of the slope. It says the slope is 0.23 or 0.24. So the length of the deliberations will increase by 0.24 of an hour for the length of each trial per hour. And find the meaning of the y-intercept. The y-intercept is 1.26. So that would mean that jury deliberations would take 1.26 hours if the length of the trial was 0 hours, which is kind of goofy. And then predict the length of the jury deliberations for a trial that lasts 8 hours. So this is going to be extrapolation because it's outside of our data. Let's see, 8 hours. All right, so let's do this. Point y equals 0.24 plus 1.26. All right, so they want us to predict the length. That's 8 hours. So if I plug 8 in there, and I'm going to grab myself a calculator. Glad you got your work out. Look at you. Wow. 0.24 times 8 plus 1.26. So this would be 2.86. So this would mean if we had a trial of 8 hours in length, the deliberations would take 2.86 hours. And then, oh, I think you're right. Hang on, I didn't plug it in right. I put 0.2, I didn't put 0.24. Plus 1.26. What'd you get? 3.18?
Yeah.
Oh, without really bright people like you, I would be just all wrong. And then predict the length of the jury for a trial that lasts 40 hours. Yikes. I don't want to have a 40-hour. So 0.24. Hmm. 0.24 times 40 plus 1.26. So if it was 40, that would give me a 10.86. Yikes. Is that about right?
Yeah.
Cool. And then which, if any of the above predictions are invalid, explain why. So this is extrapolation. So I would say that's probably invalid because we didn't have anything close to that. The 3.18, we did have stuff that was 8 hours. So that should work. Huh. And then calculate the residual for the trial that took 12 hours. Okay, so I'm going to take 12 and plug it in. Okay, and then I have to look back at my data. 12 hours was 3.5. And then when I plugged in my data, I got this. And I plugged in my line of best fit. So if you think about this, 12 comma 3.5 is the data. But my line of best fit, that's where my line of best fit is going to fall, but 12 comma 4.14, so I'm going to subtract those. So 4.14 minus 3.5. Ah, shoot. 4.14 minus 3.5. So we get a residual of 0.64. And actually, I went backwards. I'm sorry. It should have been 3.5 minus 4.14. So that should have been negative. We have negative residual. And then explain the residual calculator. The problem means in the context. For the trial that lasted 12 hours, the jury deliberations were over-predicted by 0.644 hours. And then the residual plot on your calculator. In your own words, describe what the residual plot shows, what conclusion comes up with regarding the regression model. So the residual plot appears to show a random scatter. Okay, so if I went back to this and I plotted my residual, which are my blue dots. So it seems to be a random scatter. It doesn't have a fan or anything like that. It doesn't act like a parabola. And then we doing okay back here? It seems like an awful lot of conversation. Maybe I'm just hypersensitive to it because my ears were clogged and it just went. You know when that happens? It's always the best. Okay. Sweet. Okay, and then use a scatter plot below for each equation. So sketch where you believe the linear regression would be. Okay, you're just trying to make a straight line. Use your regression to predict the explanatory value at 40. I'm actually not going to have any of those on the test, so I would not sweat those. Yeah, I'm almost positive that's not there. So, all right. So, I could assign you stuff, or I could just say, hey, get the full sheet ready for tomorrow. I would strongly encourage you that anything from chapter 2 could be used. Okay, so just take a look at that. Deal? You know what to do? Or did you want the one extra assignment? I didn't think you guys wanted it. All right, so you know what to work on? Yeah, because it's chapter test. So a front and back and even the edges.